In this video, we're going to take a look at some of the features of the Universal Render Pipeline and how we've used it to build out our BoatAttack demo project. The Universal Render Pipeline is optimized for open and flexible rendering, with scalable graphics quality to meet device performance. This allows you to achieve maximum quality graphics on high-end devices, while maintaining performance on low-end ones. We built the BoatAttack demo to act as a small vertical slice of what you can achieve using the Universal Render Pipeline, and we're continually updating it to take full advantage of the latest Unity features. Thanks to the Universal Render Pipeline, the demo is designed to work on a wide variety of platforms, including mobile devices and current consoles. Let's take a look at some of the ways we've achieved this using the Universal Render Pipeline. Many of the materials used in this demo are built and designed using ShaderGraph. ShaderGraph is an artist-friendly interface for creating shaders, allowing you to rapidly prototype the look of your materials without needing to write any code. The cliff shader in the demo is a great example of how powerful ShaderGraph can be. We use the normal vector of the mesh to draw a grass texture on parts of the cliff face that are pointing upwards, and we then use the world space height to make sure that the grass only appears on points of the mesh that are high enough and away from water. We've also used ShaderGraph to simulate wind on vegetation and perform individual vertex animations. We've built a series of nested subgraphs to calculate the wind effect using various repeating math calculations. But that's not all. We have also used ShaderGraph to build the materials for the boats that players can customize, the houses that light up at night, and the card-based clouds in the background. ShaderGraph has been an extremely valuable tool in making the BoatAttack demo and ensuring consistent graphical quality across multiple iterations of the project. Another great feature of the Universal Render Pipeline that we are using is custom render passes. Custom render passes are a way of injecting scripts and effects into the render loop to influence rendering of certain materials or objects. We used scriptable renderer features to add 2 extra rendering passes for the water rendering, one for caustics and one called water effects. The caustic scriptable renderer feature adds a pass that renders a custom caustic shader over the scene between the opaque and transparent passes. We render a large quad aligned with the water to avoid rendering pixels in the sky. The quad follows the camera, and the shader is additively rendered over what's on screen from the opaque pass. The water effects pass is slightly more complicated and adds effects to the water as objects interact with it, such as splashes and foam. To do this, we render objects to an off-screen render texture using a custom shader and write different information into each channel of the texture. Another great feature of the Universal Render Pipeline is the volume framework and post-processing volumes. Post-processing volumes allow for fine-tuning of post-processing effects on cameras throughout the scene. We can use global or local volumes for fine control over post-processing features such as anti-aliasing, depth of field, motion blur, bloom, lens distortion, chromatic aberration, color grading, and more. In follow-up videos, we'll be going into more detail about the features of the Universal Render Pipeline and explore how the BoatAttack demo was built and how you can achieve some of the techniques in your own projects using the Universal Render Pipeline in Unity. To learn more about the Universal Render Pipeline and to try out the BoatAttack demo for yourself, follow the link in the description down below. Thanks for watching.